Okay, so to prove that v squared is equal to u squared plus 2ac, it's very simple, guys. There's no need to even stress. So what you need to identify first is what you're having in the formula. What is the formula telling you? So me, I can say the formula is telling me that this is final velocity. So final velocity squared should be equal to initial velocity squared plus 2, then this is acceleration. Now what is s? This is known as the displacement or the distance. Okay, so the main issue is just finding the formula for displacement. Okay, so the formula for finding displacement, we say displacement is equal to final velocity. So you open brackets, then say final velocity plus initial velocity divided by 2 close brackets multiplied by time. Okay, so this is the formula for finding displacement. This is displacement. Take note of that. Now you can see that in our formula here, the one they want us to prove, there is no time there. Okay, so what I need to now do is to find the formula for finding time. Okay, so that while there is time here, I replace it with the actual formula. Okay, so how do I do that? So I'll just say, since I want to find the formula for finding time, I can use the formula for acceleration. Okay, you know that acceleration is equal to final velocity minus initial velocity divided by the total time taken. Okay, so here I can find the formula for time. I can make time the subject of the formula. So I'll say, what is the formula for finding time now? So to equate or to evaluate for time, I'll just balance here. I put a 1, then you cross multiply. A times t, that is a t, is equal to 1 by v, that is still v, 1 by negative u, that is still negative u. So that we want now time. We want time. That's our main interest. So I'll just say we divide both sides by a so that time remains alone. So that a and a goes. So the formula for finding time should be equal to final velocity minus initial velocity divided by the acceleration. Okay, so now since I have the formula for time, so here where there's time, here exactly here in the formula for displacement, here where there's time, I'll put this formula because we're saying t is equal to this. Okay, so where there's t, I'll put this. So I'll come back to my formula and say s is equal to, open brackets, final velocity plus initial velocity divided by 2. Then while there's time here, I'll now put this formula, the one I found here, which is saying v minus u over a. Okay, this is very simple. After that, now you just multiply here on top and down. So you multiply the numerators and the denominators so that you have something like this. So displacement is equal to v times v, that is v squared. Okay, so that is v squared. Then negative times positive times negative, that's a negative. Then u times u, that is u squared. Then 2 by a, so we say divided by 2 by a, that is 2a. Okay, I hope this is very clear. All right, then now here, if you look at the formula that we're proving, this one here, the formula that we're proving is for final velocity squared. Okay, so here in the formula now, I'll just make this one the subject of the formula. How do I do that? So I'll balance here by putting a 1, then cross multiply. So 1 times v squared, that is v squared, is equal to 1 times negative u squared. Oh, sorry, take note. So 1 times v squared, that is v squared. Then 1 times negative u squared, that is negative u squared. Then that's when you can say equals to. Okay, take note. So you multiply 1 with all this here. Then you also multiply s by, which is this side. Okay, so what is s times 2a? That is 2a s. Okay, we're almost done. Then now here it's just making this one the subject of the formula. So negative u squared will come this side so that we have something like this: v squared, or final velocity, is equal to, if negative u squared crosses the equal sign, it becomes positive u squared. Then what is it? This is positive 2as. So you say positive 2as. As simple as that. And you always say hence proven. As simple as that. Okay, so this is the final answer, which means we've proven that.